What is up, stats nerds? I'm Professor Charlie Collins. Welcome to another feature of Current Mode, where we aren't mean, we're just average. Today we're talking about bivariate analysis for variables that are continuous, broadly speaking, of course. Specifically, we will cover Spearman's row and Pearson correlation. Both of these analyses should be available in any statistics package under the correlation command. Bivariate analysis with continuous variables is useful because they can help us answer three questions. Does an association or relationship between an x and a y variable exist? How strong is the relationship? And what is the direction of the relationship? Using bivariate analysis with continuous variables allows us to study a variety of relationships, such as the relationship between parental income and children's academic achievement, the relationship between exercise frequency and self esteem, or the relationship between job satisfaction and employee turnover. Let's talk about levels of measurement. A continuous ordinal variable is a type of variable where response options represent a ranking or order, but the distance between each response is not necessarily the same. You will often find continuous ordinal variables represented in Likert type scales. So let's consider a scale of, let's say, 1 to 10 that measures the pain of a hospital patient, with 1 being no pain and 10 being severe pain. This would be considered a continuous ordinal scale because there's a specific order or ranking to the values, but the difference between each value is not necessarily the same. Right? So a score of 4 is greater than a score of 2, but the difference between 4 and 2 is not necessarily the same as the difference between, let's say, 8 and 6, even though they both represent a 2-unit difference. So it's important to note that while continuous ordinal variables can be treated as numerical variables, they do not have the same properties as interval or ratio variables. And that's because the numerical values assigned to responses for ordinal variables are arbitrary, right? They represent something, but not necessarily a number. And they're arbitrary because they only represent a ranking, right? So alternatively, numerical values assigned to responses in interval and ratio variables represent actual numbers, right? So, for example, the numerical values in, let's say, the measurement of time, age, income, height, and distance in miles all represent real numbers. Spearman's row, also known as Spearman's rank order correlation coefficient, is a measure of the strength and direction of a relationship between continuous ordinal variables, or rank ordered variables. It is most typically used when it's not possible or appropriate to use Pearson correlation coefficient. It is useful to study something like the relationship between, let's say, university ranking and academic achievement, or something like political conservatism and colorblind racial attitudes, for example. And the output for Spearman's row is the same as Pearson correlation, and it ranges from -1 to 1, where -1 indicates a strong negative relationship, which means that as one variable increases in ranking, the other variable decreases. 0 indicates no relationship, so there's no real order to the relationship. And 1 indicates a strong positive relationship, which means as when the x variable increases, so does the y variable. Pearson correlation. It's a measure of the strength and direction of a relationship between variables measured at the interval or ratio level. Pearson correlation is useful to study something like the relationship between age and income, or something like time spent on social media and self-esteem, for example. Like Spearman's row, as I mentioned before, the output for Pearson correlation also ranges from -1 to 1, with the same types of relationships. Now let's think about this. I want to give you a couple of ideas for you to run with and kind of practice on your own. So I have 3 questions for you. 1, when should you use Spearman's row instead of Pearson correlation? 2, what are a few examples of variables used for Spearman's row? What types of variables, for example? And 3, what are a few examples of variables used for Pearson correlation? Thank you for watching Current Mode. I will catch you next time.